Next, we have Casey Schaufler presenting on why kernel security is cool again. Please welcome Casey.
Thank you, thank you, thank you. So kernel security is, once I turn the switch on, thank you. Okay, I'm Casey Schaufler. I've been doing kernel development for the past, I actually looked at it the other day, it's like 40 years. And I've only been doing security for the past 30. So I'm a relative newcomer to it. But one thing we see working in security is that it gets cool for a while, and then it cools off for a while. Then it gets cool for a while and cools off for a while. Now we're in a cool phase. So people want to work on security. People like security. And the question is, first question, of course, is why? Yeah, what happened? Well, thank you. What happened that all of a sudden security is cool again? Well, one of the things that happened last year, we had a couple of exploits for hardware that had been around for decades. It had been actually well known in the security community that these things were here, but people started publishing them instead of academic exercises as exploits, and all of a sudden, crying and gnashing of teeth. And a lot of effort and expense has started going into addressing these kinds of issues. Another thing that happened, and this is a kind of a community kind of thing, is that GR security went dark. For a long time, GR security was the place you went to see how to do arcane and interesting lockdowns in the Linux kernel. That project decided to take its public face away and not actually just present that out to everybody anymore, not be open about it. And that got a lot of people's attention. A lot of people who were just saying, well, yeah, this kind of stuff's over there, we can kind of think about it, but GR security handles that. It's not going to happen there anymore. That stuff's never going to get upstream. If we care, we got to do something about it. Containers. Containers are really popular. Anybody here use a container? There's one in every room. And containers want to do a whole lot of things to make it easy for you to set up your environment so you can run your thing without bothering anybody else. And the kernel isn't set up that way. It's set up pretty much for people to interfere with each other in all kinds of interesting ways. So the people who are doing containers want a set of enhancements to make the environment they're running in better for the kinds of things they want to do. And the last thing I want to touch on here is 1980s security is for squares. Okay, how many of you really understand the Bell and LaPadula security model? Three, okay, there are four. Oh, there's a fourth one over there. All right. The security models that we brought with us from the 1970s and 1980s don't really work well on a whole lot of the modern systems we're using. So one of the things that's going on these days, people are saying, why do I even have user IDs? Why do I want to clutter up my system with all this information that I'm never going to use? So these are the reasons, the basic reasons why security is cool, because we got to do something about all these things that aren't kind of right, that we want to do something about. So first thing here is of course hardware. Okay. What are we going to do about the hardware stuff? Well, we're going to fix some hardware security bugs. Okay. The operating system is the first, well, depending on how you want to look at firmware, which I don't. The operating system is the thing, but it's that nice little layer there that smooths out all those little bumps and crags in the hardware. So this is what a lot of the Spectre and Meltdown stuff has been. How do we address the fact that people who make hardware are really, 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 really clever, and the people who use it don't want to be clevered to death? And we also discovered that there are multiple architectures you have to deal with. Well, yeah, if you've got an Itanium, it's going to have a side channel attack that looks like this. You've got a Xeon core, it's going to look like this. You've got an ARM processor, it's going to look like that. If you've got a MIPS processor, it's going to look like that. So the operating system, this is a lot of interesting stuff. Now, if you really want to wrap your brain around these things, it's an area where you can come in and say, oh, here's the obvious solution, and look at it and go, wait a second, that's not going to fix the problem. So there are a lot of people who have a lot of brains, a lot of smarts, who can now work on security and do fun stuff. We also get a bunch of people, okay, once you start having hardware people being told, oh, well, you know, we've got all these security problems with your hardware, they say, okay, great, we like that. We're going to implement security features. You know, we're not going to fix the bugs, that's what software is for. But we are going to introduce a whole lot of features that make our system so much more secure than the other system that nobody's ever going to buy those chips again. We're going to put new memory models in. We're going to put memory protections. We're going to encrypt the cache lines. That'll really speed things up for your database. And we're going to isolate, you know, we're going to have 6 processors on this chip, and 3 of them are going to be dedicated to doing these things, and 3 are going to be dedicated to doing those things. And they're not going to be able to talk to each other except through this except through the second level cache on odd Tuesdays. Dealing with the clever that the hardware people can come up with is, again, one of these interesting things where you can make use of the interesting ways that people who develop hardware think software people work. And then, of course, there's the boot process. All right, my system's running, it's running great. Well, okay, how do you know that the system you're running is the one you want to run? What do you mean? It looks like it's running what I want it to run. It's like I can show my slides, yeah. Well, yeah, but how do you know it's not also sending all your security, all the credit card numbers you've got here off to some place in Wellington? Ugh. Well, I watched it boot. Well, how do you know it didn't lie to you when you watched it boot? Ooh. Well, because I installed the operating system myself. Well, how did you know that the operating system it booted was the one you put on, not one that it downloaded while attestation. Attestation signatures, there's a whole plethora of stuff going on here. There are people at IBM who are running a Linux kernel to boot the Linux kernel. And how you get the Linux kernel that you're booting the Linux kernel with is itself a very interesting process. And of course, you can't just burn it into prom, because if you do that, then of course it's got a bug, you can't update it, and everybody's on. So it's a very interesting problem with a lot of fun things to do to make it actually come out right. And of course, the better job you do, the slower it's going to be. And that's going to interfere with your database again. Okay, so the next thing is kernel hardening. What is kernel hardening? How many of the people here have not heard about kernel hardening? Okay, there's one person who hasn't. Great. And how large a rock do you live under?
It's a hard rock.
Ooh. There are 2 in this room. Okay, so kernel hardening is really just a response to 50 years of bad coding. If you think it through, if there are 24 million lines of code in the Linux kernel, which is the count I came up with last week, that means there are 24 1 in a million errors in the kernel. That's an awful lot of 1 in a million. Oh, there's a 1 in a million chance that this could be a problem. Well, there's 24 of them right there. And people still haven't learned things like, I can do a stern copy. Well, stern copy is safe, right? Now, the fact that I'm taking the length of the data from user space, it's okay because I've put under user on my variable, and so it's okay. We still see this, and we've learned a lot, though. It's like we have. Yeah, there was a time when, back in the old Unix days, there were things in the kernel that nowadays you'd get fired if you even thought about talking about. But there's still a lot of errors out there. And we've got new techniques for dealing with them. Anybody here remember running lint? Okay, there we have it, yes. You used to do make, and then when the thing all compiled, you'd go, oh, great, and then you say make lint, and then you'd cry for about half an hour. It was really brutal because lint would actually say things like, hey, that's a pointer over here, and that's an integer over here, and they're not the same size. Why didn't the compiler tell me that? Well, compiler just figures out you're smart, right? So we have a lot of new compiler tricks too. A lot of options you can give to the compiler to warn you about things that you shouldn't be doing, but that you probably are, and that have always worked. And warnings that'll say, hey, you know what, maybe this should be a const. Maybe you shouldn't take this void pointer and put it into there. Maybe you shouldn't do this kind of arithmetic on this kind of data structure. And we got scanning tools. We got proprietary tools, we got open source tools. I'm personally an advocate that you run proprietary tools on open source and open source tools on proprietary, because you got different mindsets. And different mindsets looking at the same bit of code are going to see different things. Containers. Containers are neither a kernel nor a security construct. If you talk to the container people, they were adamant that, oh no, containers are not a kernel thing, and they're not a security thing, unless of course you're talking to the marketing people who are going to sell it as a security thing. But yeah, namespaces on the other hand are a kernel construct, and they are security features. Now, I used the Lone Ranger here because he always wears a mask, so you don't know who he is. Trigger, on the other hand, you do know who he is because he's been mapped into your namespace. The point being that we've got all kinds of namespaces. We've got file system namespaces. We've got mount point namespaces. We've got user namespaces. We've got development going on security namespaces within security modules. So you can have a different AppArmor policy, for example, on your base system and in each of the containers you're running, which is kind of cool. It's also kind of strange. If you've been working on security at all, you kind of get into the mindset of, well, we know what secure is, and then we say, wait a second, but we know secure is this here, and it's that there, and it's, if we have them both, then do we have a combination or an exclusion, or, oh my goodness, my brain has exploded. Which is fine, because it's cool. Now we got new security models coming in. Again, the security modules we've got currently, we've got four major security modules. Tomoyo is the only one that's actually modern in any way. AppArmor is actually a pendulum swing against Bell and LaPadula. The notion of what Bell and LaPadula says is wrong, we want to have the other alternative here, and that's AppArmor. SMAC is a generalization of Bell and LaPadula, and SC Linux is an overgeneralization of Bell and LaPadula. But the new modules we've got coming in sometime soon near now. We've got Landlock, which allows you to put a BPF program on every system call in your program. So this is a self-protection thing. So you're demonstrating self-control here. You say, all right, I'm going to put this BPF program here, and anytime I run, say, open, it's going to run this program on the path name and tell me whether or not I can do that. You might say, well, why don't I just write my program correctly in the first place so that I don't have to worry about it doing that? But this is coming in the mindset of somebody's going to hack my application anyway, or I've got Node.js running on top of it or some such thing. And I know bad stuff is going to happen, and when it does, I want the program to stop because I can't do anything to prevent these people from doing these wild and crazy things. I've got another one called SARA, and it implements a bunch of memory protections. And it has a plug-in mechanism, so you can implement additional memory protections. It can do filtering on the USB stack. So it offers you a number of protections that you don't have right now. And it's configurable, so you can do all kinds of fun stuff. But this is not your father's security module. WhiteEgret. This is kind of an interesting one in that all it does is prevent you from executing programs. Now, why don't you just turn off the mode bits, I hear you cry. The idea is that in addition to checking the mode bits, you then have a list of programs that you're allowed to execute, and you can turn them off or on and at will. And this is a level of protection even if you've got a read-only file system, for example. And you can dynamically change it. Another thing we've got going is security module stacking. This is my personal baby here. I've only been working on it for 7 years. So we'll get this completed more or less real soon. But the idea is that when the security module infrastructure was put in place, nobody thought you would ever want to do more than one kind of thing, that every security module would take care of all the security for the system. And that model would just suffice for everything. We've learned that doesn't work very well. Okay? You want to be able to pick and choose what kinds of things you actually want to protect. So what this is going to allow is allow all the security modules to play together nicely. So here we have, they're playing jump rope. Sorry, it was the best metaphor I could come up with on the short notice here. The other thing that this is allowing new modules to come in and work in concert with the existing security modules you have. So if you have SE Linux on your Fedora box and you want to try some new and interesting security model, you'll be able to do that without having to turn SE Linux off and upsetting your IT department. How many of you, by the way, have IT departments that want you to run SE Linux? Well, no, I saw several. I saw several. Of course, they all work at Cisco. But there is value to keeping what you have and adding to it, rather than necessitating that everything be thrown away at every time. So the question is, how can I join the fun? Okay, let's say you want to be one of the cool kids, live the security engineer rock star lifestyle. What can you do? Well, the most prominent project that's going on right now is the Linux Kernel Hardening Project. And for that, you just need to find this guy. I am embarrassed. Case Cook, who will be talking various times during the conference today, you can find him in many places, has been running the Linux Kernel Hardening Project for the past couple of years, and it's actually been amazingly successful. After years of not having hardly any work done on hardening seriously upstream. It's now going gangbusters, and he's the one you need to talk to about getting things, what you should do, what will be readily available. The other thing you can do is you can do your own Linux security module, have a security model that makes sense for you. What can you do? What do you want for security? You probably don't want Bell and LaPadula. You may not want your mode bits. What do you want? What does your application, what does your system, if you're running like the processor in this, what security model do you want? If you're running the processor on the security module, if you're running a supercomputer center, what security model do you want? We want to be thinking in terms of now and what makes sense today. Now the future. What does the future hold? Because now that computer security is, that kernel security is cool, what kinds of things are we going to have coming up that we'll want to work on? Connected devices are probably the first thing. There are no users, again. What? Okay, there are no users on my little clicker thing here. So what's security policy? Do I need user IDs? Android already took over the user IDs and then discovered that if they wanted to have a multi-user phone, they were in really deep trouble. So what do we want here? And the other thing we're going to have, you've got your smart vacuum cleaner out there. Okay, how smart does it need to be? Does it need to be smart enough to go over to your control panel there and call in the aliens? Probably not. Do you want something, do you want to have a vacuum cleaner that's so smart that when you throw it away, you have to have a funeral? Again, probably not. But what security models do we want in that? Special purpose processors. Okay, what are the security implications of having all these smart little devices hooked up to your computer? You have a GPU. How do you share your GPU? You got 6 users on your system. You got 400 GPUs. How do you make sure that the right person gets the Bitcoin? You got your crypto processors. How do you get them integrated in? Your storage processor, your TCP offload, who knows what? Your FPGA that does some magic calculation that makes everything better. Another area people can be working on. And of course, just because we know how things work, there are going to be lots and lots of bugs. There are going to be lots and lots, as quickly as we're working at hardening the kernel, people are going to be introducing more bugs that we're going to be detecting because we're making things harder. And we'll be mitigating, but still, you don't want to have to have the mitigation when you can detect it and fix it in the first place. That is actually a picture of the first computer bug. It was a moth in a relay. So there we have it. That's why kernel security is cool again. That's why it's a great place to work. It's a great place to contribute. And it's a place where you can do your bit for humanity and mankind. Okay, so thank you. Any questions? Okay, so the question is, how long is it going to be cool for? Generally, we can count on 18 months. No, okay, so this current phase of it being cool is about 6 months. We're about 6 months into it. So we've got about another year. And then How long will the hiatus be? Probably 2 to 4 years. No, and then yeah, we'll see. It's like this one. This is actually a very strong cool period because of Spectre and Meltdown.
Hi, I have a question. You talk about mixing security models together. You mentioned like SE Linux and APARA. When the different security approaches sometimes conflicting, how do you see the overlapping or working together in that model?
Okay, so when security policies conflict, what you get is this wonderful situation where you have a brick. And there really isn't a whole lot you can do about that except soften one of your approaches. So yeah, if you want to have, for example, a system that has strictly capabilities where you don't have a super user and you want to have SE Linux, you are going to have a system that is going to be very first off, your security is going to be power of 2, and your usefulness is going to be inverse power of 2. Just because the friendliness of it is going to be inverse power of 2. It's not that that's bad, it's that that's what you're asking for. And yet, it's one of those things where if you ask for something really, really important from technology and it's delivered, you have to deal with the fact that it's been delivered. Going once, going twice. Thank you. Oh, actually, no, wait a second. Wait, hold the applause.
So presumably, a lot of this work going into kernel hardening and whatnot is going into mainline kernel.
That's the idea.
Yeah. What about us doing embedded devices where we're at the mercy of our vendors that giving us kernel that's in like ancient?
Okay, so the question is what about when I'm getting a binary, a non? Okay. Backport. All right, so when you're getting, when something new comes out that makes things better, and you've got something old and you can't move forward, what do? You backport. Okay, and if that's less painful than moving forward, then you win. And if it's more painful, then you lose. But this is, it's the old problem. There are still devices out there running 2.6 kernels. There are lots of devices out there running 2.6 kernels. There are lots of devices out there, in fact, most of your phones, running 3-point-something kernels, even though we're on 5 now. So it's an age-old problem. It's the balance between updates and stability. There is no magic bullet on that. If there were, it would be great. It would be awesome. You should get at least a master's degree for it. Okay.
Yep. Oh.
Sorry, I was going to say, you generally tend to do security by defense in depth, and you don't rely only on the kernel to secure you.
That's true. And thank you, the networking stack. But if your kernel is compromised, then what you do in application space has limited use. If your hardware is corrupt, then what you do, again, it has limited use. So there's the defense in depth, which says, yeah, we've got 7 layers here, so one gap isn't going to be a problem. On the other hand, you then have the chain analogy, which is if one link is dead, then it doesn't matter how strong the others are. And it's a balance. Defense in depth has its places. I've also seen it done to death, done to the extent that you've got this and 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 this, and eventually they just throw it all away because it's so cumbersome and has such performance impact that you aren't getting the use out of the machine that you want. So yeah, that's one reason why some of the new security models come in, and you can say, and this is what I really care about. And so I'm just going to attack that. And I don't, yeah, the user's ID stuff I don't care about. So it's there, but yeah, I'm not going to count it. I can just use the thing that I really do care about.
Hi, I am here. Slightly hypothetical question from manager point of view, PHP kind of point of view. If I'm building a new system, exascale type, hoping that it will last 50 years, how many nights should I lose sleep in terms of security? Or which are the opportunities that I have to do things relatively right? It's just an open question.
So if you're coming at security from the point of, okay, so the question is, yeah, I'm going to be deploying this system. It's going to be out there for years. I'm not going to be able to update it. I can design it. Okay. You can design it. Whoa, whoa. There's a concept. And that's really your best answer. Is yeah, the better job you do identifying the environment you're going into, what your threats are, and what you care about, the better off you're going to be. One of the things that most people forget about when they design, they'll do what they call a threat model on the system and the environment it's going into. They forget what it is they're out to protect. And they put in all kinds of things to protect all kinds of things they don't care about and leave the thing they do care about vulnerable.
Yeah, because what I care, it's not necessarily what the other users or funders do care, which
That's
is not
right.
a strange conundrum, I guess.
Yeah, so the question is often, what do you care about? And a lot of people come into software design with the notion of, well, somebody's taking care of that. So I'm just going to, yeah, the system is all secure, so I'm just going to just assume that that's good because I don't want to have to worry about it, which is one reason why we get treated like rock stars, because we come in and we save the day all the time. Okay, anybody else? Well, thank you very much.